Good afternoon and welcome to today's briefing for the crew of the newly announced Hubble Space Telescope servicing mission. We'll begin today with short introductions and some comments, and then we'll move to Q&A. This press briefing will be about an hour, and it will be followed by a photo session with the crew here at the Johnson Space Center. I'd like to begin by introducing the commander of the mission. To my right is Scott Altman, who is just recently retired from the U.S. Navy as a captain, and he's a graduate from the University of Illinois and has a master's degree from the Naval Postgraduate School. He's been a Navy pilot and test pilot and has logged over 4,000 hours in about 40 different aircraft. He entered the astronaut corps in 1995 for initial training, and then moved to 3 different shuttle missions. The first was STS-125 in 1998, where he served as a pilot. Next was STS-126 in the year 2000, when he again served as a pilot on an early mission to the space station. And then in STS-109 in the year 2002, he, as well as John Grunsfeld and Mike Massimino, went to the Hubble Space Telescope for a servicing mission. And with that, I'd like to hand it over to Scott so he can introduce his crew and take a few comments.
Thank you very much, Doug. I just want to echo a comment that I heard this morning at the announcement. It really is a great day for discovery, for exploration, and I think for NASA to be able to go back to the Hubble Space Telescope, extend its life, keep its vision out there. Just a tremendous opportunity for science and I think for the future. The discoveries we don't know about yet, the observations we haven't taken. It's just a really thrilling for me, for all of us, to be a part of the team that's going to work on that. And we really are thrilled to be a part of that team that's been working to keep Hubble alive, and hopefully we can extend its reach for an additional period of time. I want to introduce the crew, spend a little bit of time with them. We do have an extremely talented group of individuals with me. I'm just so proud to be a part of this team and looking forward to the work in the future as we get ready to fly the mission. To my right, we have Greg Johnson, call sign Ray J, fellow naval aviator and test pilot school graduate, although he went to the Air Force test pilot school. He worked with me previously when I was in the Shuttle branch, so we've had a great working relationship, and I know he'll be a phenomenal PLT on this mission. I'd like him to just spend a couple minutes introducing himself.
Well, thanks, Scooter. It's really a privilege and an honor to be here. When I gave a lot of talks to kids at schools, they always ask about the Hubble, so I actually put a Hubble set of slides together to talk about what the Hubble does for science, and to be able to be a part of the crew to extend the mission for 5 years is really special for me, especially on this Halloween day. I never dreamed that as a kid flying seaplanes in Seattle, trying to put myself through the University of Washington, that I'd be able to fly in the space shuttle. So it's really an honor. A lot of people will say it's not really what you do in life, it's who you do it with. And I can honestly tell you this crew is just awesome. Great to be around, and to be part of the Hubble servicing mission is just the best I can think of. So it's been a lot of experience to get here. I'm proud to be here, and it's going to be a great part of the crew, and I'm ready to start training. So
great.
Thanks.
Great to have you on board. Next to AJ, of course, is an old friend of Hubble's, visited it twice already and looking forward to a third time, John Grunsfeld. I think I'm just thrilled to be reunited with him, looking forward to working again. He's probably the most knowledgeable and experienced person in our office on Hubble, also experienced with spacewalking, and he'll have his share of that on this mission, and I'll turn it over to John to expand on that.
Thank you, Scooter. It's really a tremendous team that's assembled here. I'm very excited that we're going to go back to Hubble, and I think this is a wonderful crew to go do it. We have a lot of experience with you, Scooter, with Mike Massimino. As Barbara Mikulski said this morning, it's a great day for science. It's a great day for exploration, discovery, and the inspiration that Hubble provides and will continue to provide with the new servicing mission. People have talked about our STS-109 crew as the crew that were the last folks to touch Hubble, the last human beings to touch Hubble. And it's just amazing that we're sitting here today, thanks really to the very hard work of the people in the Shuttle program and all across NASA who have put together the tools, the techniques, so that we can fly back to Hubble and that we can fly to the International Space Station as safely as we possibly can. So it's remarkable that we're here to talk about this. And thanks also, to, of course, to the folks at the Goddard Space Flight Center and the Telescope Institute who have kept the dream alive, who have kept Hubble doing great science, and who will continue to keep Hubble moving forward in discovery until we are able to get there sometime in 2008.
Thanks, John. And of course, to his right is another former member of the crew, Mike Massimino. Did 2 spacewalks on STS-125, was a rookie back then, but now comes to this crew as a leader and experienced shuttle crew member who's going to be doing a lot of the work and leadership for the EVA task. Mike?
Thanks, Scooter. It's a real pleasure for me to be here today with my friends on this crew. I was very excited when I got assigned to my first flight to Hubble, and being a rookie, I was just thrilled and looking forward to it, like I know Megan and Mike and Drew and Ray J are. But I think I'm more excited this time, and I think it's because I know what's ahead of us. The opportunity to fly in space and view the Earth and work on the Hubble is an extraordinary privilege. It's a real blessing. And a chance to be a part of the Hubble team again is something I'm very much looking forward to. They're the best group of people anybody can work with. The folks at the Goddard Space Flight Center, the folks we have here that we work with at the Johnson Space Center, and people around the country and around the world that support this great project. For us to come in and be a part of their team for a couple of years and get ready for our mission is just a real privilege. So it was a highlight of my professional career doing it last time, and just so thrilled that I'm going to have a chance to go back and do it again. So thanks.
Great, Mike. Great to be working with you again. Now, Megan Macarthur, the next member of the crew to Mike's right, joins us as a rookie from the class of 2000. She has a background in aeronautical engineering and also oceanography. She's blended those two things in undersea adventures and research. Now has an opportunity to apply those talents that she's accumulated into robotic skills as we explore that great ocean of outer space. Megan?
Thanks, Scooter. Obviously, I'm very happy to be here. I'm thrilled to be on this team. It's still sinking in, and really looking forward to working with this crew and getting to be a part of the Hubble team. Hubble is a really special instrument. The science resonates with people worldwide, and it's a very special opportunity for me, and I'm very grateful to be here. Thanks.
Great, Megan. Next to Megan then is Drew Feustel, a fellow classmate from the class of 2000. He has a background in geophysics and geology. He also shares my enthusiasm for classic car restoration, except I think he has probably more skill and experience at working on that, and we're looking forward to letting him use those skills as we work on the Hubble telescope. Drew.
Thanks, Scooter. I want to echo what everybody else has said, that it's a pleasure and honor to be here. One of the things that I've told myself recently and my kids is that with opportunity comes obligation. So we're all here. We have a great opportunity. We're obligated to do a good job and do the best that we can do. And I want to take some time to thank the people who got me here, my family, my wife, my kids, my parents, and all the educational institutions that helped get me here, and the work environments as well. It's been a long, arduous path for me, but yeah, I'm really pleased to be here, and I look forward to working with all of you folks on the crew. It's going to be hard to concentrate having so much fun, like I'm sure we will, but we're all here to do the job and do it well. So thanks, Scooter, and everybody else for supporting us on this mission.
Great, Drew. And the final member of the crew to introduce this morning is Mike Good, who's an Air Force colonel, aeronautical engineer, Air Force Test Pilot School graduate, flew F-111s operationally, also helped develop the B-2. So we're thrilled to have him as a member of the team, bringing his operational experience to the work that we're going to do on Hubble. Mike?
All right, thanks, Peter. Well, as you've heard everyone else say, it's flying in space is a team sport, and that's never been more true than on this Hubble mission. I'm excited to be a part of this team. I mean, I don't think excited really comes close to describing it, but we're all looking forward to getting started with our training, getting into the training flows and working with the different teams from really across NASA. All the different centers are involved. I know that today there's probably a lot of excited and happy astronomers and astrophysicists, but there's an equal number of happy students and teachers out there that have used the Hubble as a training tool and a learning tool. So we're looking forward to going up there and just making Hubble as good as we can, really optimizing its performance to a new all-time high. And So we're just really looking forward to that, and so that Hubble can continue to, inspire and explore and discover the universe.
Thanks, Mike. I find myself getting all motivated and inspired just listening to the comments of the crew. So I can't wait to get out there and begin working and training to develop this. This is the opening chapter, opening step of a long journey. The flight is scheduled for May of 2008. We have a lot of work to do to get ready, but this is just a tremendous start. You can tell we're all thrilled to be here and be a part of this team. Looking forward to working with the rest of the NASA family as we embark on this great mission. Thank you very much.
Excellent. Okay, thank you, Scott. And we'll start off with questions down here in Houston. And start with Mark. Please give your name and affiliation and give us your question, please.
Thanks. Mark Carreau from the Houston Chronicle. I have a question and a follow-up. My first is for John Grunsfeld. Can you talk a little bit about how helpful it is to have the experienced members on your crew go back and do this mission? There's 3 of you that have been there before, so what I'm looking for is how helpful is that?
Sure. Hi, Mark. Thanks for coming. I think it's very helpful. We have a flight crew that has 3 folks who have been to Hubble, and the rest of the crew consists of rookies. And so I think it's our opportunity to pass on to the rookies our experience, and also to provide a measure of certainty that we know the telescope, we know the training process, and it's a risk mitigation. We have demonstrated performance. Mike did an awesome job on the last mission, and I think together, we'll be able to put together a team, as we've just started today, that will get to Hubble as an experienced crew. So I think it makes a big difference, and we've done that since the second servicing mission, had some carryover.
Thank you. And for Captain Altman, there's been some talk, of course, about how this mission differs than the other missions that the shuttle will fly before retirement, in that you're going to the Space Telescope, there's no safe haven. What's your assessment of the risk of doing this kind of mission versus one where you have the space station to use as a safe haven if there was some difficulty that couldn't be repaired?
Well, we have looked very hard at the safety of this mission and evaluating that against the standard, really, of having the space station there as a space haven. And we've come up with a strategy that I think ends up equalizing the risk as much as we can, but taking our own safe haven along with us, being able to shelter in place until another shuttle came up and got us if that were to happen. But the first thing is making sure that we've handled the risk, the source of that problem, as well as possible. We're collecting data from all the shuttle flights right now, and it looks like we've made a great step in that direction to limit the risk of ascent debris, control that as much as possible in order to stack as many things in our favor as possible to make it very, very unlikely that we would come to a launch on need mission requirement.
All right, next, go ahead.
Robert Perlman with Collect Space. How long have you been a crew? When did you learn that you were assigned to this mission? And when you were told, did you have any immediate questions about it? How much of the mission plan were you told about?
I think we should have one of our rookies answer that question with getting hold. How about you start out, Ray J?
Well, we were notified in advance, not a whole long time in advance, but I had been tracking the Hubble a little bit for the Space Shuttle program in the astronaut office, so I was aware of what the mission was about and the complexities of the mission, and then also discussing the launch on need options. I talked to John Grunsfeld. John's kind of the office expert on the build-up to Hubble and helped get it back as a mission on the manifest. So we've talked to launch on need, and but we were notified just a little in advance, and just enough to get prepared for this press conference. So,
Megan, you have anything to add on this?
Well, no, just what Ray J said, that we were just real pleased to hear the news, and a few of us have been able to work as the team was investigating possibility for potentially going to do a servicing mission. We had the opportunity to do some of the development work earlier this year, and so learning a little bit about the telescope, but obviously still have a lot to learn. So.
Yeah. I guess I'll wrap that up by saying I didn't fully believe it until I heard the words come out of the administrator's mouth this morning at the press conference. So that's when I really started getting excited.
Next up, Gina.
Gina, ABC News for Mike. Mike, talk to me a little bit about the complexity of some of these spacewalks. I know you've done some training, and we've talked about the 110 teeny tiny little screws. That, how complex will that be for you all?
The flight, there's some things on the flight EVA-wise that has been done before. The wide field camera, the cosmic origin spectrograph is a big instrument that is similar to the ones that we've changed out on previous missions. But the task you're referring to is the Space Telescope Imaging Spectrograph, the STS, which needs a repair done to it to remove a main electronics board and put a new one in. And that involves removing a panel that has 110 non-captors, small little fasteners that need to come out, so you can remove this panel and get access to this board that needs to come in and out. And when we first heard about this task, I think the reaction of John and I and the folks up here, that anyone that heard about it said, well, you got to be kidding. There's no way you can do this inside of Hubble in these little fashions. How are you going to do this? But the Hubble team that we've been referring to are a pretty amazing bunch of folks, and they're very innovative. And the idea they came up with was to come up with a capture plate, what we call the Fastener capture plate, that they'll be using, that will attach to this panel, and then it allows you through a piece of Lexan with small holes in it, allows you to put a drill bit more or less inside of the hole, undo the fastener, and as the fastener comes out, it will be captured behind that Lexan, so it won't cause any damage, but you can still get access to it and be able to get all those done and remove the panel and have access to the instrument, replace the electronics board, and put a new panel on top of it. So that's the new innovative task, and that's a brief overview of it. There's new tools and techniques that need to be developed for it. So that's the one that's going to require the most development.
Commander Altman, what's the kind of gee whiz, oh boy part of going back to Hubble for you?
Every time I talk at a school or do a presentation and I show some of the pictures that the instrument we put in last time made possible, and I look at that, I'm just amazed at the universe we live in, and to have the opportunity to go back to the instrument that makes all those observations and photos possible to expand our understanding of the universe, it's just thrilling for me. And I know the moment as we rendezvous and close in and you look out the window and you actually see Hubble up there as we approach it, it's just an incredible exhilaration to see it there as you close in.
Go ahead, Jim.
Jim Oberg with NBC. My question is, you don't seem to have the exclusive position of being the last visit to Hubble because you're installing equipment for the next visit. Would you describe the optional future visits to Hubble, future vehicles, manned or unmanned, that you might expect to be able to get to Hubble in the next decade or so?
Well, there's quite a few different options. I'll let John talk a little bit about that. Of course, the administrator this morning pointed out that this is the last shuttle mission planned to visit Hubble, and will install the capability, I think, to access it with other means, one of which was referred to as the CEV. And John, you may have some more information on that.
Well, the first question is, what kind of Hubble lifetime can we expect from the shuttle servicing? And you've heard numbers like 2013. And that's bantered about because that's the requirement for a servicing mission, is that after you go and repair and upgrade the telescope, you get 5 years of additional life, science life out of the telescope. History has shown, and especially with the current 2-gyro mode that we're operating under, we should be able to even get more life out of it. One of the requirements for this mission, though, is to put on the capability, whether it's sensors or targets or actual mechanisms, so that at some point we can deorbit Hubble safely. And that's something that's called the soft capture mechanism. And so we're installing that on the bottom of the telescope, and that is the device that will enable other spacecraft to dock with the Hubble, either to deorbit it or to service it, depending upon where we are in space technology at the time. If we don't do anything, Hubble will deorbit by itself just because of atmospheric drag, as little as it is, sometime around 2025. So we have quite a bit of time to be clever and to work out ways to provide a deorbit capability, but also possibly to service the Hubble. And as we heard this morning, the crew exploration vehicle is not out of the question. And in fact, it's an interface that's common to the crew exploration vehicle. So it may be a derivative, or it may be something like that.
Follow-up to that. For the new members of the crew, you've seen this tradition of people reflying to Hubble. Are you good for one mission, or two, or how many? Would you like to go back to Hubble 10 years from now?
Mike, you want to take that? Mike, good?
Sure. I think I'm just, as I said before, excited to be assigned to a space mission, and I never dreamed it would be to Hubble. And of course, I would go back again on any future space vehicle if that, if that became a possibility.
All right, that looks like that completes the first round of questions down here. Excuse me, at the Johnson Space Center. We'll go to the Kennedy Space Center next, where I understand we have 3 reporters. Go ahead.
Elaborate a little more on when you found out about who was going on the mission. I think Greg said he just found out shortly before I guess the announcement today, but I'm assuming Scott, John, or Mike, you all might have known a little bit sooner, and I was wondering what kind of training have you all been doing so far, and have you been to Goddard for any of that training? And just if you could answer that, and then I have a follow-up, please.
Mike, you want to talk a little bit about the work you've been doing on Hubble preparing for this?
As far as when you find out, I guess we really knew for sure this morning when the administrator said this is what we were going to do and who was going to be on it. And luckily we were able to all get into the same shirts, which is what we've been really spending our time on the last day or so since we found out. What has happened since about a year ago or so, when there was some discussion about the possibility of going back to Hubble with a shuttle, what that servicing mission might look like. And because of that, the folks at the Goddard Space Flight Center and the Hubble team started looking at what they would do if they were able to have a mission, because you need a couple of years really to get ready, and they didn't want to be behind if it was announced. And so they looked at some of the things they would be doing, what the EVAs would look like. We've talked about a few of the things, the STS task of replacing, instead of replacing the entire instrument, doing a repair job on an instrument in place, and also the soft capture mechanism that we've talked about that you might go up to with a future vehicle to rendezvous with. Things like that that would require some new development they started looking at in more depth. And they asked for help from the astronaut office and from the folks here at the Johnson Space Center and other places. And so a few of us, a bunch of folks from our office were able to participate in that. And we had a couple of visits up to the Goddard Space Flight Center to look at the tools that were being developed and gave our opinions. Being experienced Hubble crew members, we were able to give them some of our experience and knowledge and work with them to develop those tools and techniques. And we've also had some events down here at the Johnson Space Center, but those have just been preliminary development events that we had. And now that there's a crew assigned, we're going to get into it real heavy and hit it real hard. But we laid the groundwork, and Chuck Shaw's led a team down here at the Johnson Space Center looking into the Hubble mission, and we've been a part of that as any way we could. So it's been preliminary stuff, but now we're ready to go full blast. Pause here.
Yeah, and as a follow-up, could you talk about how the training will progress over the next 18 months and what the different stages of the training will be?
John, you probably have the best handle on that right now.
Sure. As Mike said, the work up to this point has been developmental or engineering work, and we've had a number of folks from the astronaut office involved in that. Now that we have a crew, we can go forward with the actual crew training part of the EVA task, of the shuttle tasks. And because we've been to Hubble several times before, the template is somewhat well understood. There are still some complexities, and Space Telescope Imaging Spectrograph task is one of them, that there's still some details to be worked out. But we'll start in earnest, as soon as we can get everything organized, training for the NBL, training in 1G, situations for some of the hard stuff. And that will involve a crew being in the NBL almost every month from now until flight. We have at least 12 roughly sessions of 5 NBL runs each, which is in the large pool in the spacesuits. And so that's going to occupy a lot of time. A number of trips up to Goddard to work with the real hardware, down to KSC as we get closer to flight. And of course, all the shuttle mission training in the simulators here at the Johnson Space Center, flying the shuttle training aircraft. And it'll be a full plate.
This is Stephen Young with SpaceflightNow.com for John Grunsfeld. When Sean O'Keefe took the decision to cancel the servicing mission, you were one of the most vocal supporters of that decision. I'm just wondering what's changed in your mind personally since that time for you to not only, I presume, change your mind and also be part of this mission.
Sure. Well, I think your opening statement was incorrect. I supported Sean O'Keefe's decision as the administrator of NASA, and whether I agreed or disagreed with the decision was really irrelevant. There's a big difference between a risk taker, and quite honestly, you're looking at 7 risk takers up here on the stage, and risk managers who are responsible for undertaking risk on behalf of the astronauts, on behalf of NASA, on behalf of the country, and in the case of Hubble, on behalf of people all around the world. And Mr. O'Keefe made the decision as NASA administrator, as the chief risk manager for the agency, at a time where he had data in front of him that led him to that decision. And when the administrator makes a decision like that, it's up to the team to support that decision and to make the best out of it. And what we did as a team was to make sure that the Hubble science was supported, that we had a plan going forward that at least in principle would allow us to keep Hubble producing science as long as possible, and that would not prevent us or preclude us at some future time in going back with the shuttle, pending the data that was available to either the current administrator or a future administrator. And what we saw this morning was that Mike Griffin reviewed all of that data as the current risk manager for the agency and made the decision that given the tremendous progress that we've made on the shuttle program side in terms of safety and in terms of understanding the risks for ascent debris, for what we can do in terms of safe haven on the shuttle, for inspection and repair, on the basis of all those considerations, he reinstated the mission. And it's because we were able, as a team, starting with Mr. O'Keefe, leading to Administrator Griffin, to keep the program alive and keep the science going. I think it was Mr. O'Keefe who said it best. When he made the decision, and I was sitting next to him at one of the press conferences, he said, this is a difficult decision. And he said it's not one that everybody is going to agree with. And in fact, he said there are plenty of astronauts, and he pointed to me, and he said there are plenty of astronauts, including John Grunsfeld, who, if given the opportunity, would be first in line volunteering to go on such a mission. And I can't necessarily say I'm first in line. I'd say it's a 7-way tie. And we're all just thrilled to be here today.
Todd Halverson of Florida Today, also for John Grunsfeld. Given what you've seen on the first 3 post-Columbia missions and the safety enhancements that you were just discussing, I'm wondering if you can give me an idea of what your own personal assessment of the risk of this particular mission is, and whether you think it's safer or more dangerous than previous Hubble servicing missions, given the fact that you guys would not be able to seek safe haven on the space station.
That's a wonderful question. In fact, that's one Scott Altman and I were discussing this morning. And I think we both agree that a mission in 2008 will be much safer than the STS-125 mission to Hubble that we flew in 2002. The tragic loss of Columbia is one that hits us all very hard. And I know from some members of the folks sitting up here who were involved, and I'm sure for everybody, but involved in the Columbia recovery effort, this is still a very tough time. The lessons that we've learned from that, and all of the incredibly hard work from the best and brightest of NASA, is what allows us to fly missions like STS-114, STS-121, and STS-115, the 3 missions we've flown so far, with ever-increasing safety. And we're going to keep watching that. We definitely did learn from Columbia, and we're changing our culture, and we're going to keep watching safety every single mission including Hubble and including the missions after that. I feel like, you've all heard me say this before, but I feel like a mission to Hubble is worth risking my life for. It's something I discuss with my family. It's something that's really important for our country, and I firmly believe that the next mission to Hubble will be much safer than the missions that we've flown before. Scooter?
John, I'd just like to kind of follow on to that because I think the same thing. Looking back at when we launched on STS-109, we had our understanding of the risk. Maybe we didn't know as much as we thought we did then, but now, as I look back on what we've learned from then to now, the improvements that we've made, there is no doubt in my mind at all that the next time we go to Hubble, it will be significantly safer than when we launched on STS-109. And I'm prepared to do it, and I know the whole crew is ready to go.
And just a quick follow for Mike Good. I'm wondering how you as a rookie feel about the risk involved with this mission from where you sit as a first-timer.
Yeah, we've talked about that at home, my family and I already. And as you've heard, yeah, there's a risk, and we all feel like it's worth the risk. The reward is worth the risk to go to Hubble. And as I said before, to really optimize its performance and to bring it, into its best capabilities. As you've already heard, from these guys, that we've done a lot. We've come a long way since Columbia, and I feel good about that. We have inspection capability, we have repair capability, and we have a launch on need mission that's going to be on the pad waiting if we do need it. So, this mission that we're going to go on is going to be, the safest of all the shuttle missions up to that point. I think each mission just keeps getting safer and safer.
Dan Billow at WESH-TV for Commander Altman. You've touched on it a little bit, but let me ask you to kind of go over it again or elaborate. What steps are you going to take, and Mike just mentioned one of them, but what steps are you going to take on this flight to kind of minimize the risk or minimize the fact that you don't have a safe haven up there?
Well, probably the biggest one is that we're flying this time with an on-orbit inspection capability, just like the return-to-flight missions have all had. We'll be able to inspect the vehicle, determine its condition. Of course, we're EVA capable with all the EVAs that are planned for Hubble. So if we do find any damage, we'll attempt to repair it. If it turns out that is unsuccessful, as Mike alluded to, the plan is to have a shuttle on the launch pad ready to go. We'll kind of shelter in place by reducing the power load, extending up to 25 days on orbit while we wait for a shuttle to come and be our ride back home, just the way the station crews do when they shelter on board the ISS and wait for a shuttle to come up and pick them up to bring them home.
All right, that completes the questions coming out of Kennedy Space Center, and now we'll go up to NASA headquarters. We have one journalist there, I think, that has one question.
Tracy Watson, USA Today for Dr. Grunsfeld. I wanted to follow up on Stephen Young's question. You had the unenviable position a couple years ago of having to participate in the news conferences about the cancellation of SM-4, and I'm wondering if you can give us a little more insight into your opinions at the time. Did you think it was an inadvisable thing to do despite your own willingness to go?
That's a tough question to answer, and you have to, in order to understand the environment, you have to kind of rewind the movie to 2004, shortly after the Columbia accident, and understand the mindset of everybody in management. We were still reeling from the loss of Columbia and the tragic loss of the crew. I had to reconcile in my own brain, my feelings about my love for the Hubble program, all the people who have spent their lives working on, generating the great science, and the reality of what we could actually do with the shuttle program. And where I put myself was trying to project back to, a previous tragedy, which was Challenger. And so the mind frame that I put myself in was to ask, you know, what did people do after Challenger? And I read a lot, and I talked to other astronauts who were around and went through that. And the answer was actually a pretty simple one. What Mr. O'Keefe said as NASA administrator is that we're not going back to Hubble with the space shuttle. And so I asked myself the simple question, you know, that's a decision. It's really important that our leaders make decisions and that we follow them. But what's also interesting is, and happened in Challenger, there were payloads that we had on the books that were also very important payloads. And after the loss of Challenger, people said, well, if we can't launch them on the space shuttle, how can we launch them? And we came up with alternate means of getting payloads to space that were very important national security payloads, and also experiments. Some experiments that were going up on the shuttle went up on expendable launch vehicles. So I asked this question, if we can't service Hubble using the shuttle, how can we service Hubble? And out of those simple questions, in discussions with Goddard and other folks, came the concept or potential for doing robotic servicing. And the robotic servicing was actually a very useful exercise. You heard Mike Griffin this morning say that he thought it was not a viable alternative. And while that may be well true, what it did allow us to do is to continue working on the Hubble program and continuing to develop the instruments and the techniques that we might use for servicing. And a little bit earlier, you heard Mike Massimino talk about the Space Telescope Imaging Spectrograph repair and the 111 tiny screws. The way that we're planning to service the STS instrument now was actually born by the requirement of doing that same repair using robots. And that's a totally crazy idea. We never could have done it using robots. But the essential idea of how we're going to handle all of that came out of the robotic servicing program. So to answer your question, the way I was able to reconcile my own feelings about the decision was to push forward and try and figure out a way that we could service Hubble.
Okay, I believe we have a follow-up question coming out of headquarters.
You're going to be primarily responsible for the onboard. Can you tell us a little bit about what doing inspection without this ISS there for the crew to take photos from will entail?
Yeah, I think that was directed to Megan as the arm operator.
So we're interested in learning about the inspection capabilities that we'll have when we're not at the space station. We'll carry the orbiter boom sensor system, which has a package on it that we'll use to inspect the various areas on the orbiter that we would be concerned about. We'll carry that capability with us, and it's not a requirement to be at the space station in order to do that type of inspection.
Thank you, Megan. And now we're going to go to the Goddard Space Flight Center for a single reporter there.
MSNBC.com. I just wanted to get straight in my own mind how the spacewalks were going to be organized. I assume there are two teams of spacewalkers, and are you going to have the experienced folks divvied up so that they're on the two teams? Or have you gotten that far?
Well, I think you've basically just encapsulated about the point that we're at the moment. You can make those assumptions. There'll be two teams, and we'll split the experience, and we'll figure out which tasks go to which team and who exactly is on each team. Anything more than that, I'll defer to my EVA leads.
Scooter, you hit it exactly. I think the bigger perspective is we have 5 EVAs on this flight that are planned. Each one is currently full of tasks. I'm sure you had a good briefing from the folks there at Goddard, but we're going to put in 3 new rate sensor units, which have 6 gyros total. We're going to change out the batteries. We're going to put a new wide field camera in, which is the camera that really, this new wide field camera is going to be incredible. It can see in colors that the human eye can't see, and it's really going to be the tool that allows us to see deeper into the universe than Hubble has ever been able to see before. We're putting in, as you know, the Cosmic Origin Spectrograph, which, as Mike said, is one of these large refrigerator-sized instruments. And then we're going to replace a fine guidance sensor, which is one of the things that makes Hubble so good, that it can point so great, and then repair the Space Telescope Imaging Spectrograph. There are a few other small tasks in terms of the outer insulation on the telescope that will give it a little bit longer life. But that's a lot of stuff to put on the plate, and we'll do that with 5 EVAs. Mike and I will be split on different teams so that the experience is spread out. And as Scooter said, that's about as far as we've gotten.
All right, that'll complete the questions from outside JSC. We'll come back here to Gina.
Gina Sinceri, ABC News for Drew. You've got kind of a long history of tinkering in your garage, so I think you're going to give a lot of hope to every other kid who's out there tinkering in the garage that this too could be a career path for them.
Sure.
So tell me how that tinkering, will translate into working on Hubble. A lot of difference between a Jaguar and a Hubble?
Yeah, there's a tremendous amount of difference, but for me the key is just familiarity with tools and working with tools, and I think that for all the folks that do EVAs and work on EVAs on the space station or Hubble, what's critical to performing those successfully is having that experience and some of that background, some familiarity to work with those tools. And much of what we do is like working in the garage. At least that's the way I see it. And in fact, every time I'm in the garage, I think of it as currency training. And we do a lot of training in sims here at JSC and everywhere else, flying and whatnot. But when I'm in the garage, that's my currency training. So it's a good excuse that I can provide to my family for a reason to go into the garage and work. But other than that, I mean, that's really the key. And all the folks that are on this mission are very skilled at EVA type of work, and I think it's going to be an outstanding opportunity for all of us to do some great things to Hubble. So looking forward to that.
Thank you. Go ahead and help Drew out a little bit. On every Hubble servicing mission, the tool development is really crucial. Because when we're up there, we can't exactly call down and say, hey, can you send up a new tool? This one doesn't work. So the tool development is really crucial. And at least on the last couple of flights, one of the best sources of inspiration for new tools is to go to the hardware store and see what's current. And so I've used that as an opportunity to stock my garage, and I'm sure Drew will do the same on this mission.
Go ahead, Mark. Mark Ruff, Houston Chronicle. I have a couple. I guess for Scott Altman, I'm visualizing the inside of the shuttle crew cabin. There's 7 of you, and you have to plan for the possibility of almost a month. Where are you going to put all the tools that you're going to bring on this mission versus the supplies you might need to stay that long?
It is a challenge, the packaging challenge. I look back at the last mission on Columbia servicing Hubble and how packed the mid-deck would get from time to time. We actually, on the flight deck, looked forward to the spacewalks because that meant 2 people were outside and not taking up so much space, and it was always with a little bit of reluctance that we opened the hatch to let them back in. But we did every time, Mike and John. So on this flight, though, you're right. There's an additional challenge we didn't have before with the additional supplies, LIO to scrub the atmosphere, food for us to survive on. But we also have the benefit of now having an external airlock, which gives us a little more internal room. Some of the supplies we can put out in the payload bay because we know if we'll need them later, we'll be able to use one of our EVAs to go get them. So I think we have a lot of work ahead of us on the final packaging, but it looks like it's all doable to keep us up for nearly a month.
Thank you. And I had a question for anybody that this might grab, but I'm wondering how this mission and the mission of Hubble overall, how you all might see that fitting into NASA's new exploration mission. Is there a bridge there? Is there something that your mission and the role of the Hubble Space Telescope in studying the universe sort of ties that together? Does that grab anybody for something?
Well, I'd like to get that from a couple of folks. Drew, you've been working exploration for quite a while now at different things, the desert rats and different suit things, Nemo. I'd be interested in hearing your thoughts, and John, I'm sure you have some comments as well.
I guess I can just start by saying what interested me this morning when we heard the briefings at Goddard was what Ed Weiler talked about and sort of with Hubble bridging the gap, looking out into the beyond. And as he said, the moon's very close, Mars is a bit farther away, but it's that beyond step that I think Hubble really gives us. And in my mind, in considering all of this and thinking about Hubble over the last few months with the development work that we did originally, what's impressed me the most about Hubble is all of the information that's returned to us about the universe, and it's the one piece of scientific instrumentation that we have that really provides some key insight into what's really out there, what's out in the beyond. So in that sense, I think that's where we get the biggest return from it, and we'll continue to until its eventual retirement.
I think Drew hit a good part of that, and in the original vision that the President elucidated for NASA, the beyond played a big role, and in part it was the search for Earth-like planets outside our solar system. That's part of the really big question about are we alone, and Hubble is a part of that. Hubble, I think, is a part of returning to flight, as Mike Griffin announced today. Hubble is about returning the shuttle to flight. It's one of the best marriages of human space flight and the science program. But Hubble is just one of the constellation of NASA satellites and spacecraft that's dedicated to science. And what's so remarkable about Hubble is it makes discoveries on its own, but it also makes discoveries in concert with the Spitzer Observatory, the Chandra Observatory. Hubble is continuing to make discoveries in concert with our constellation of spacecraft around Mars. And the story on Mars just keeps getting better and better, with Mars Reconnaissance Orbiter now just about to enter its science phase from its engineering phase. I think we're going to see the Hubble Mars Reconnaissance Orbiter partnership really explode. I think the other area is, believe it or not, the moon. For many years we thought that the moon was too close for Hubble to observe. If Hubble tries to look at the moon is moving really fast. Well, last year we showed that the Hubble is really a great telescope and unique in its capability, especially looking in the far ultraviolet, in the ultraviolet where our eyes can't see, to look at the moon. And so we may have opportunities there again. In particular, with the Lunar Reconnaissance Orbiter and the LCROSS mission, we're going to have two spacecraft that are going to go into Shackleton Crater, or we think Shackleton Crater, and it's going to send up a plume of material. And much like Comet Shoemaker Levy 9, we're going to see this plume of material, and hopefully we'll leverage the Hubble Space Telescope to look in that plume, because again, it will be uniquely able to understand what's there. And one of the big questions, surprisingly, is there water on the moon? And that's one of the objectives of that probe. So Hubble can play really some key roles in the science areas, but also in just inspiring kids to go into science and engineering. Hubble has done that for the 16 years it's been producing wonderful science, and it's those young kids who go into science and technology that are the ones that are going to carry the vision of exploration forward. And somebody who's maybe in high school now, maybe in grade school, might be the person who's inspired by some Hubble science who goes on to be a member of the first crew to step on Mars. I think that'd be pretty exciting.
Thank you, John.
Robert Perlman with CollectSpace.com for Commander Altman. In the remote possibility that you would need the Launch on Need shuttle to come up, how exactly would that unfold? Would there be, if it's known, are there going to be EVAs between the two shuttles? Do they dock? How does that work?
Actually, there's no way for the two shuttles to dock to each other, but the next best thing is to basically be berthed together using a robotic arm to latch on to a grapple fixture and provide basically a stiff path between the two vehicles. So you could move the crew on a spacewalk from the stricken shuttle onto the rescue shuttle and then bring them home like that. It would take basically the bulk of a day to make that transfer, after a few days for the other shuttle to get there and rendezvous with you. With one sitting on the pad, we're trying to minimize the time it takes from determination of the need to getting the crew up there and bringing them home. So there is a technical solution that looks like it will work to provide us that launch on need capability for that remote opportunity.
That's it there. Jim, go ahead if you have one.
Jim over to NBC. John, can you comment on there was some pressure early on to fly this mission as soon as 12 months from now. There's some people wanted to fly it October, November of 07, and that is clearly not been decided on. Can you summarize the arguments for flying it even sooner, and perhaps the reasons why they didn't win the argument?
Well, the argument is really simply a technical one. And there's two sides to it, one of which is how soon can a crew get ready, how soon can we get ready, and the other side is how long will Hubble last. And when we started having this discussion about servicing Hubble, the big issue was, well, there are two issues actually, but the big issue was the batteries. The belief was that by sometime in the end of 2008, some people said as early as the end of 2007, that Hubble's batteries would go bad, and that would be the end of Hubble. Well, again, the really creative folks who operate the Hubble figured out what the best charge and discharge algorithm is, the best method of charging and discharging the batteries, and then also they recently finished an assessment last August of what the current battery charge is, and have determined that, in fact, 2008 looks very favorable, and that maybe 2009 is the time at which we start to become more concerned about the batteries. I think the battery story in itself is a remarkable story. Those batteries were produced around a year before the launch of the Hubble, so we're talking about more than 16 years ago, and these batteries are fleet leaders in space. I don't know how many people terrestrially have any batteries that even come close to lasting that long. Usually we're thinking about laptop batteries, lasting only a few hours, and for a year or so of cycle discharge. And these batteries are in space, a tough environment, and going on 16 years, and it looks like they should last another couple of years. So that pressure's been taken off. But nevertheless, the gyros are still a story, the fine guidance sensors is still a story, and that's more related to how long does Hubble produce productive science. And in the science community, there's always a worry that once Hubble can't produce good science, of course, their work stops. But also, when you look towards the end of Hubble's life, whenever that may be, in 2013 or 2015, that the sooner we get these new scientific instruments up, the Cosmic Origin Spectrograph and the Wide Field Camera 3, Wide Field 3, that the sooner we start producing that science and the more science we'll get out of it. I think that's an important point, but certainly a second-order point. The real question is, how long can Hubble go before it can't be serviced? Related to the science instruments going up there, though, is something that we hear every time a crew is named and every time a mission is put on the manifest, that the biggest discovery that Hubble will make is the next one. And a lot of folks don't believe that, but from the last mission, we were told that, and there was this small discussion about something called dark energy, which we now know is about 75% of the total energy content of the universe. And prior to the previous Hubble missions, nobody even knew it existed. So I think that's pretty big. I don't know how we can top that, but I imagine there'll be something.
That's the money quote. Thank you.
All right, thank you. It looks like that'll wrap up our questions here. And to close it out here, I'd like to turn it over to Commander Altman for a final statement.
Thanks, Doug. I just wanted to close by thanking everybody for the interest, support, and attention. It is a huge team effort, and as I've been sitting here listening to the comments, the questions, and the answers, I remembered a night when I was 10 years old, and I went outside on a summer evening and looked up at the moon and realized that a person from this planet was now standing on that moon. And I also looked out at the stars that night, and I wondered what was out there. How could I go out there? And I know we're all thrilled now to be a part of the Hubble team that really does take us out to those stars and bring that home with us. We're all just tremendously excited and thrilled to be on the team and looking forward to the work we have in front of us and making Hubble continue to be the success story that it is.
Diese atemberaubenden Bilder aus den Tiefen des Alls haben wir dem Weltraumteleskop Hubble zu verdanken. Weder von Wolken noch Atmosphäre gestört, liefert es gestochen scharfe Aufnahmen von Objekten in Millionen Lichtjahren Entfernung und das schon seit 18 Jahren im Orbit.
Hubble war wesentlich erfolgreicher, als wir jemals angenommen hätten. Man kann sagen, dass es die Astronomie revolutioniert hat. Es lieferte Bilder aus dem fernen Universum, von denen niemand vor dem Start Hubbles geahnt hätte, dass sie überhaupt existieren.
Hubble berauschte die Sternenforscher mit spektakulären Bildern und neuen Erkenntnissen über die Astrophysik.
Die großen Teleskope blicken zurück. Sie sind im Grunde Zeitmaschinen. Das ist ein ganz erstaunliches Konzept, dass man ein Teleskop nehmen und damit lange und tief genug zurückschauen kann, bis in die Frühgeschichte des Universums. Es sind Objekte aus den ersten Tagen des Universums. Wir sehen sie, wie sie damals aussahen. Dann drehen wir dasselbe Teleskop ein Stück weiter und schauen auf eine nahegelegene Galaxie. Es ist ein fossiler Rest der Frühgeschehnisse. Wir benutzen das Teleskop wie eine Zeitmaschine. Erst schauen wir 13 Milliarden Jahre zurück. Im nächsten Moment betrachten wir unsere nähere Umgebung und verstehen, wie sie so werden konnte, mit ein und demselben Teleskop.
Hubble schwebt in 600 Kilometern Höhe über der Erde, also in einer durchaus erreichbaren Entfernung. 4-mal waren Astronauten zu Reparatur- und Wartungsarbeiten im Orbit. Für kommenden August ist die letzte Expedition geplant. Danach soll das Teleskop noch weitere 5 Jahre in Betrieb bleiben. Unser Wissen vom Kosmos hat das Superauge im All entscheidend beeinflusst. Doch weil es ein optisches Teleskop ist und im sichtbaren Lichtspektrum arbeitet, ist seine Reichweite begrenzt. Schon kurz nach dem Hubble-Start träumten Astronomen deswegen von seinem Nachfolger.
Es gibt eine große Lücke in unserem Wissen über das Universum. Wir können die Strukturen der Frühphase des Weltraums nach dem Big Bang untersuchen, mit Hilfe von Missionen wie COBE und der künftigen Planck-Mission der ESA. Und wir können Galaxien erforschen mit Hilfe von Hubble. Doch diese Erkenntnisse passen noch nicht zusammen. Wir wollen verstehen, was geschah, damit Galaxien und Sterne entstehen konnten und damit auch der Ursprung unseres Lebens.
Hubbles Nachfolge, das James Webb-Weltraumteleskop JWST, soll die Lücke schließen. Es arbeitet im Infrarotbereich. Nur so kann man durch Staubwolken hindurchsehen und ferne Objekte erspähen.
Einer der Gründe, warum das James-Webb-Teleskop so merkwürdig aussieht im Vergleich zu Hubble und anderen Erdteleskopen, ist, dass es ganz besonders leicht sein und sich zusammenfalten lassen muss, damit es in die Trägerrakete passt. Ein weiterer Grund für sein merkwürdiges Aussehen ist, dass es vor der Sonne geschützt werden muss.
Um Infrarotstrahlen aufnehmen zu können, soll das Teleskop an einem kühlen, dunklen Punkt 1,5 Millionen Kilometer von der Erde entfernt stationiert werden, bei einer Temperatur von minus 240 Grad Celsius.
Es muss so kalt sein, denn Infrarotstrahlung ist warm. Wir versuchen, die Wärme von sehr kalten Körpern im Weltraum zu messen. Das Teleskop muss kälter sein als das Messobjekt, sonst nimmt das Teleskop nur das Signal seiner eigenen Wärme wahr.
Ein Teil der Tests, denen sich das künftige Teleskop unterziehen muss, findet in den britischen Rutherford-Appleton-Labors nahe Oxford statt. 4 entscheidende Instrumente werden sich an Bord des Superspähers im All befinden. 2 davon sind europäischen Fabrikats. MIRI ist ein Infrarotspektrograph samt Kamera, ein hochempfindliches Messgerät, das bahnbrechende wissenschaftliche Erkenntnisse verspricht.
Zu den wichtigen Funktionen von MIRI gehört, dass es Bilder machen kann. Damit wird JWST Aufnahmen weit entfernter Galaxien liefern können, auch von Trümmerringen und Planeten in der Nähe von Sternen. MIRI verfügt auch über einen sogenannten Integralfeldspektrographen, mit dem man Spektroskopien von Objekten durchführen kann. So lässt sich etwa die chemische Zusammensetzung eines Körpers analysieren und nach Elementen wie Methan oder Kohlenstoff auf Planeten und in den Trümmerringen junger Sterne suchen.
In Ottobrunn bei München wird MIRIs großer Bruder NIRSPEC gebaut. Dabei handelt es sich um eine Nahinfrarotkamera, die uns dabei helfen soll, die Entstehung von Sternen zu begreifen.
Ein Spektrograph misst die Strahlung von Himmelskörpern, zerlegt das Licht in sein Farb- bzw. Wellenspektrum. Das liefert den Forschern Analysemethoden, mit denen sich die Zusammensetzung des Objekts bestimmen lässt, dessen Temperatur oder ob es rotiert. Das ist ein entscheidendes Instrument zur Untersuchung neuer Objekte, Sterne, Galaxien, junger Galaxien im Frühstadium, unmittelbar nach ihrer Geburt.
New objects, stars, galaxies, young galaxies in its early stage when they are just after their birth.
Mit seinem Spiegel und seinem gigantischen Sonnenschild ist JWST das größte und komplizierteste je gebaute Raumobjekt. Schon kurz nach seinem Start 2013 soll das Teleskop die Geheimnisse des Universums erforschen.
Eine der fundamentalen Fragen ist, welches die ersten strahlenden Objekte des Universums waren. Der Ablauf der Universumsgeschichte ist in groben Zügen bekannt. Es beginnt mit einem Big Bang, produziert einen großen Feuerball, der sich immer weiter ausdehnt, bis er schließlich durchsichtig wird. Und dann ab einem bestimmten Punkt schahen Dinge, schwarze Löcher bildeten sich und Sterne entstanden. Und dann begann auf einmal eines dieser Objekte, ganz gleich welches, zu strahlen. Das erste Licht im Universum nach dem Urknall.
First light in the universe after the Big Bang.
Es wird schwer, auch mit dem James-Webb-Teleskop. Aber dieses erste Licht ist es, was die Menschen wirklich sehen wollen.
Ungeduldig erwarten die Sternenforscher die ersten Bilder vom James-Webb-Teleskop und den großen Zeitsprung zurück zur Geburtsstunde unseres Universums.
The crew carrying out the final servicing mission on the Hubble Space Telescope is led by Commander Scott Altman, retired from the U.S. Navy as a captain. Altman is a product of Central Illinois, born in Lincoln and raised in Pekin, about halfway between Chicago and St. Louis.
I started off at 3 years old wanting to be a pilot, to fly. Something in me connected with that idea of leaving the Earth and flying around. And ever since then, as I got older and older, I've tried to pursue that dream.
Altman won an appointment to the Air Force Academy and was ready to live his dream.
But when I took the physical, they measured my sitting height and they said, I'm sorry, you're too tall to come to the Air Force Academy as a pilot. You could come as a weapons officer or something like that. But I wanted to fly. So I said, well, I'm sorry, I'll have to do it a different way.
That way led to the University of Illinois, where he earned a bachelor's degree in aeronautical and astronautical engineering. The Navy talked to him about coming in as an engineer, but he just asked them to send pictures of airplanes.
So they sent me back a brochure about naval aviation, and as I'm flipping through it, I see that the height requirements are different, and I'm short enough to fit in Navy airplanes. So I called the recruiter up and signed up, and then got into the Navy that way.
Based at Miramar Naval Air Station, Altman flew F-14s on deployments to the Western Pacific and Indian Oceans. He also flew many of the scenes in the movie Top Gun that were shot at Miramar. After earning a master's in aeronautical engineering from the Naval Postgraduate School and finishing test pilot school, Altman flew missions over Iraq in Operation Southern Watch and was picked for the astronaut program in 1995. He was the pilot on the 1998 Neurolab mission and the 2000 shuttle flight that outfitted the International Space Station's Zvezda module, and he commanded the 2002 Hubble Space Telescope servicing mission. 2 crewmates from that flight are with him again on this one. Chicago native John Grunsfeld was an explorer as a child, first in the back alleys of the city's south side, and then in the more suburban setting of Highland Park.
It was a very exciting time of my life, and I felt that I could go on exploring the ravines forever, and that I was a Scott or an Amundsen, especially in winter, wading through deep snow with a backpack and a big heavy coat. And I would imagine that I was on another planet and that I was an astronaut.
He decided he wanted to be an astronaut after watching the Gemini and Apollo missions on television. His interest in space and cosmology were clear when he began college at MIT.
I took a part-time job as a satellite operator for something called Small Astronomy Satellite 3, SAS-3. And so I would change the tapes and monitor strip chart recorders and make sure the spacecraft was operating, all for a couple bucks an hour, and just loved it.
Grunsfeld earned his bachelor's in physics at MIT, spent a year at the University of Tokyo doing X-ray astronomy, got a master's and a doctorate in physics at the University of Chicago, and then moved to Caltech to do research and teach.
I thought, this is fantastic. You know, this is the golden era of astronomy, and I'm a part of it.
I was studying neutron stars and black holes, which are incredibly interesting and exotic objects. I had wonderful students. I thought life couldn't be better. And then I got a call from Houston saying, John, we've reviewed your application and your interview. Would you like to come to Houston to be an astronaut?
That was 1992. In 1995, he flew on the second mission of the Astro Observatory, and in 1997, he visited Russia's Mir space station. Grunsfeld performed 2 spacewalks on the Hubble servicing mission in 1999, and 3 more EVAs on the Hubble flight in 2002. He also served as chief scientist at NASA headquarters in Washington, D.C. from 2003 to 2004. Mike Massimino, born in New York and raised in Franklin Square, Long Island, was just the right age to be awestruck by Apollo 11.
When I was 6 years old is when people first walked on the moon, when Neil Armstrong took those first steps that everyone remembers, you know. And I just thought it was really cool. I thought this was even bigger than, you know, baseball. And in New York, the Mets were winning the World Series in 1969. That was pretty big.
Though he dressed like an astronaut at Halloween and got his parents to take him to the planetarium, Massimino's astronaut dream faded. But his interest in math and science didn't. He went to work as a systems engineer for IBM after getting his bachelor's degree in industrial engineering at Columbia.
I'd always been interested in the space program, and I didn't know if I could be an astronaut like I dreamt about when I was a little kid. To me, it sounded kind of silly. I just want to grow up to be an astronaut. But when I was in my 20s, I thought about, you know, I can get a job with NASA or a contract to do something with the space program, and went to grad school
at MIT, where his work on human operator control of robotic systems in space led to summer jobs with NASA and the German aerospace program. After completing master's degrees in mechanical engineering and technology and policy, and a PhD in mechanical engineering, Massimino went to work for McDonnell Douglas, developing computer displays for space shuttle robot arm operators. Later, he taught and did research on human-machine systems at Georgia Tech before being selected as an astronaut in 1996. He made 2 spacewalks on the Hubble servicing flight in 2002. This crew's pilot, Navy Reserve Captain Greg Johnson, was born and raised in Seattle.
We were always outside, did skiing. It was a wonderful childhood. I honestly, lots of land, lots of trees, lots of water, lots of mountains, camping. It was just a great place as a kid to grow up.
Especially when the kid in question was motivated to learn and do new things. Johnson even had a plan to get his parents to send him to a college where he could learn to fly.
So I had proposed a school to my dad, and he had said, well, you know, the University of Washington is a good school he went to. And so I had kind of a plan B. Well, I'd like to do that, but then I'd also like to learn to fly. So it was sort of a negotiation of a place to fly. So I went to a community college, actually in Eastern Washington, and learned to fly there.
And he got a job back in Seattle flying seaplanes on the weekends while he got a degree in aerospace engineering at the University of Washington. He joined the Navy as a pilot and then a test pilot, completed 4 deployments at sea, then resigned his commission to work as a research and instructor pilot at NASA's Johnson Space Center. Johnson was selected as an astronaut in 1998 and served as manager of launch integration at the Kennedy Space Center in Florida for 17 months in 2004 and 2005. Megan Macarthur, daughter of a U.S. Navy flyer, was born in Honolulu and grew up around the world, Japan, England, both coasts of the United States, and she always had an interest in aviation.
For a number of years, we lived at Moffett Field Naval Air Station, which is also where the Ames Research Center is, when I was in high school. And we used to see astronauts come out there to do some of their training, and they'd park their T-38s out there on the ramp and come in for training. And I thought, well, that looks like a pretty neat job.
She became interested in the space program, but took a roundabout way to get there. At UCLA, where she earned a bachelor's degree in aerospace engineering, friends got her involved in a human-powered submarine project, for which she became the pilot, being the smallest member of the team. And while getting scuba certified, she developed an interest in ocean engineering.
And ended up working for a few months at an ocean engineering company in San Leandro, California. They design underwater robots and some manned submersibles as well. And did that for a few months, and then did sort of my post-college wandering. I went to Ireland actually for a few months, and I worked in a dive shop.
MacArthur was in graduate school at the Scripps Institution of Oceanography at the University of California, San Diego, when she was selected as an astronaut in 2000. She completed her PhD in oceanography in 2002. Air Force Colonel Mike Good is from the Cleveland area, born in Parma and raised in Broadview Heights. That's where he saw man's first step on the moon.
I was, 7 years old and, watching it on a black and white TV in my living room. And, like everybody else and all the kids thought that was pretty cool.
As he moved through school, Good became more attracted to math and science, to things that helped him figure out how to solve problems, and to aviation. He left Broadview Heights in 1980 to study engineering at Notre Dame.
I was in engineering, but made the decision to go into aerospace engineering in 1981, which was the first year that the space shuttle flew. So that definitely had an influence on me too. It's like I watched that and said, this is something that I'd like to be a part of.
The Air Force ROTC student finished his bachelor's degree in aerospace engineering and stayed at Notre Dame to complete a master's in the same field. He started his Air Force career as a flight test engineer, then became a navigator, and then a weapons systems officer. After Air Force test pilot school, Good flew and tested the B-2 stealth bomber at Edwards Air Force Base in California, and also attended Air Command and Staff College before being selected as an astronaut in 2000. When Drew Feustel was growing up in the Detroit suburb of Lake Orion, he figured traveling in space would be no big deal.
Humans went to the moon when I was about 4 years old. And I imagined that as I got older and became an adult, that traveling in space was going to be fairly common and something that we all did.
So as he grew up, he focused on things that interested him, even if they had no connection to the space program.
I started off out of high school attending community college, living at home, and at the same time working as an auto mechanic. While I was at community college, I studied industrial design because I thought maybe I'd be an automotive designer.
But he was also interested in science and studied geology. With an associate's degree from Oakland Community College, Feustel went to Purdue, a family tradition, where he earned a bachelor's in solid earth sciences, a master's in geophysics, and drove his fraternity's Grand Prix kart. He earned his doctorate in geological sciences, specializing in seismology, at Queen's University in Ontario, then worked as a geophysicist in Canada and for ExxonMobil based in Houston. He was selected for the astronaut corps in 2000. Feustel and the other 3 first-time flyers joined crewmates who've spent 95 days in space on 8 previous flights, including more than 40 days on earlier servicing trips to the Hubble Space Telescope.
Well, good morning, everybody. Welcome to NASA's Johnson Space Center here in Houston for continuation of the pre-flight briefings for Atlantis' voyage to service the Hubble Space Telescope for one last time. Joining us here is the program manager for the Space Shuttle program, John Shannon. He'll have some opening comments as usual, and then we'll throw it open for questions here and at other NASA centers. And I'll turn it over to John.
Okay, thanks, Kyle. Good morning. It was great news last Thursday morning when we started rolling Atlantis and the stack to Pad A. I just happened to be in Atlanta where we were talking about transitioning our workforce and facilities over to the new program. We've been spending a lot of time on that. So it's good to get back in the flight mode. The team is thinking about flight again and ready to go. Getting the vehicle to the pad in outstanding configuration was the result of a whole lot of work by a lot of people inside the program, and we're really ready to go. The next big milestone for us is taking Endeavour from its orbiter processing facility and moving into the vertical assembly building. We're going to put it on its specially made trailer on Wednesday. We'll roll it over to the VAB and do the mate next Thursday on September 11th. And then we expect to roll it to Pad B on September 18th. So we'll have two ready-to-go vehicles on Pad A and Pad B. We haven't seen that in a very long time. The flight readiness review of my team for the shuttle program will be this Thursday and Friday. I expect it to take 2 full days. There are some unique aspects of flying to the Hubble Space Telescope that we have not had when we're flying to the International Space Station. As you will know, when we fly to the space station and all our return to flight activities, we use the space station as an asset to us to allow us to stay on orbit for a long period of time if we had some type of a problem with the vehicle. Of course, we don't have that with the Hubble Space Telescope. And we'll talk through all that through my review boards, my program requirements control boards. We've gone through all of the hazards that we assume during an ISS mission. We've looked at it from a Hubble-specific mission standpoint and made sure that we have good risk mitigation, and I feel very good about that. One thing we will talk about, I think, quite a bit at the flight readiness review is the micrometeoroid orbital debris environment for Hubble. It's worse because we're at a higher altitude. We also don't have the advantage of putting a very large space station between us and the typical vector that we would see orbital debris coming from. We have a very good inspection plan both after ascent, where we take our boom and we move it all around the vehicle, the underside, the wings, and it will provide us a very good look post-ascent. We'll also do that for late inspection. We'll look at the wings and the nose cone very closely. But the risk is going to be higher for Hubble than it will be for ISS. And I fully expect that we will have that discussion at Flight Readiness Review. We're refining numbers. The last numbers I saw, it was about a 1 in 185 chance of having some type of catastrophic damage from MMOD. You compare that with an ISS mission that is typically above 1 in 300. So we will talk about that. And I would expect that we would carry that forward to the agency for the risk discussion. So that's something that's out there for us. We reviewed the Hurricane Gustav impacts when it went into central Florida. Of course, New Orleans was evacuated. That's where our processing facility for external tanks is, at the Michoud Assembly Facility. The report this morning, there was no significant damage at Michoud. We lost some panels from the side of our vertical assembly building out there. They've already been replaced with a structurally sound waterproof barrier that can withstand any additional storms. We got all of our team back too, and that was the important point to us. All of the team is back at MAF and processing tanks, and they're in good shape. At Stennis, they had somewhat less impacts from the storm. There was no significant damage at Stennis. It's been a tough hurricane season so far. We had Hurricane Faye. I guess it was Tropical Storm Faye, but it just sat over the Cape and rained and rained. It did not damage any facilities, but it kept the workforce from being there to process, and specifically the Hubble Space Telescope team that is working so hard to get the hardware ready to go fly. They are really our critical path for launch, and because they had to miss 4+ days of work it affected our schedule. And whereas we thought October 8th was a good day to go launch, after looking at the payload processing schedule, we moved the launch date on Friday to October 10th. And there was some thought that if we really pushed hard, we could make October 8th or October 9th. It did not make sense. You know, when you have the team coming back, picking up from a delay like we had from the tropical storm, to push them just doesn't make any sense. One day does not matter in the overall schedule at all. We want them to take the time and make sure that we get it exactly right, and that we're ready to go fly, and that we have full confidence in the payload and all the gear that we're taking up to Hubble. Now we're watching Ike, and Ike is predicted to come into the Gulf of Mexico. Where it goes, you know, we will find out. And like I told the team this morning, people and our facility protection trumps any kind of scheduled discussion at all. We make sure that we protect our people first, and then we look at the schedule afterwards to see what the impacts are. This has been a tremendous effort for the team. They've had to think a little bit differently since we're going to a different place on orbit, going to get Hubble Space Telescope. I will tell you personally, I'm extremely excited about this mission. I've been waiting for this mission for a while. It's going to challenge the team, but from everything I've seen in our past several missions, the team has all the processes in place to make good decisions, and will be able to go execute this very effectively. And I'm looking very much forward to supporting the Hubble team and getting the telescope in the best shape it's ever been. That's all.
Okay, we're ready for questions here, and then we'll check the other centers. Jeremiah, why don't we just start on the back row there, start with Bill on the corner.
Okay. Bill Harwood, CBS, sorry. John, you were mentioning MMOD odds. Would you refresh our memory on how you guys view the odds for STS-125, and how does 400 play into that? You know, somebody was saying that I guess the odds of a problem that STS-400 could save you from are pretty remote, or they're worse than the odds of on any given flight anyway. So I guess the real question is STS-400 a bit of overkill for you, given the way the odds play?
From an MMOD standpoint, which is our biggest risk to the program, I don't think 400 really plays into that decision. We have worked very hard to develop repair capabilities for micrometeoroid orbital debris damage. We've got plugs we can put in, reinforced carbon-carbon. We've got the non-oxide adhesive that we can put over any cracks or any kind of holes. I think 400 is there more for an ascent debris kind of situation, some kind of a really gross ascent problem like we had on Columbia. 400 would be very effective for that kind of case. For the MMOD case where we saw something during late inspection, if it were a case where we did not think we had repair capability for it, it's questionable whether 400 could get off the pad in time to go do any kind of a rescue. We've just started to look at the crew power configuration during the normal mission to see if we couldn't extend the on-orbit mission past late inspection additionally. That study is still in work. I think that our protection for MMOD lies in our repair capability. We've spent a lot of time doing hypervelocity impacts on RCC materials, doing our repairs and putting them in the ArcJet facility, and we've had outstanding results. So we feel very comfortable about what we have. It would take a very rare and very significant large-size damage from MMOD in a critical area to cause us to have to consider 400 for that kind of case. So to sum it up, I think 400 is for an ascent debris kind of case, not really for an MMOD kind of case.
And just one follow. What is the number overall risk as you know it today for 125, and what is it for a station flight? I mean, is it 1 in 85 or 1 in 80 or in that ballpark?
Are you talking MMOD or aggregate risk?
Everything, integrated.
Well, 1 in 80 has been put out there by the agency. I would say that our demonstrated reliability is somewhere in the 1 in 60, right? and MMOD, while being the largest component of that, doesn't move the basic risk of flying a shuttle flight that much. So it would maybe change it by a couple of points. Yeah.
Todd in the corner.
Yeah, Todd Halverson of Florida today. I've got two if I could. The first one is on the STS-400 issue. Could you tell us exactly how well prepared you guys will be in terms of whether there will be a flight control team on call on launch day, and whether the STS-400 crew will be going into quarantine on launch day? That would be 7 days before, and whether they have a mission patch.
Right. I don't know if they have a mission patch. I haven't seen one if they do. So Todd is treated just like any other flight. We've had the normal complement of team members prepare for the flight, get it from a conceptual idea to an actual ready-to-go mission. We have flight directors assigned to it, flight control teams assigned to it if that were required. The launch control team is ready to go process and launch off of Pad B. In short, it's treated just like any other flight because of the short turnaround time you would have if you had some type of catastrophic damage on the STS-125 flight. I don't expect to have to use it. And I have to repress that feeling regularly because we have to treat it seriously if we want it to be effective at all. So we have done so. It is an option for us. I feel extremely confident about two things. One is that we have improved the ascent flight environment to a degree where we're not going to have any kind of damage that would require a rescue vehicle. The second thing I feel very confident about is our repair capability. We just ArcJet tested the STA-54 tile samples that we did on that DTO on STS-123. That's right. And they passed with flying colors. So we have taken on-orbit repairs of all of our repair capability except the overlay, and we've put them in the ArcJet facility, and they've done extremely well. So I think the environment is much better. I think our repair capability is much more well understood. So therefore, the risk of 400 goes down. But when we made the decision to put 400 on the pad, we weren't at that point. And we have gotten to this point. It's just nice extra insurance to have since we're in a position that we can have a vehicle on the pad ready to go launch. So we're treating it very seriously. Don't expect to use it, but if we do, we feel very confident we could.
Okay. Will Dom Gory and his crew be going into quarantine on the 125 launch day? I mean, you're 7 days out from a STS-400 mission at that point, and I just wondered if they would actually be going into quarantine.
Yeah, and that was your specific question. I don't know the answer. We're treating it just like a regular flight, so I would assume that they would do all of the normal things they would do pre-flight to prepare to launch, which would include quarantine, but we'll have to get a real answer on what Dom and his crew are doing.
And just on a different subject, I think you've tasked some of your managers in the shuttle program to take a look at what it would take to keep the shuttle flying through 2015. And you've been winding down the program pretty much since '04. I'm wondering if you can give us an idea of how far the program has been wound down at this point, and an early assessment on your own part on what it would take to keep flying through 2015 and whether you would have to recertify the vehicle as recommended by the CABE after 2010.
Sure. That's all part of the discussion. We kicked off a study last week, and the study is really to prepare for what we anticipate would be potential questions from an incoming administration or incoming new members of Congress. So we're going to go look at it. This is a partnered discussion with our ISS program, with the Constellation program. The last thing we want to do is adversely affect the Constellation program. We have been aggressively retiring things that we did not need in the Space Shuttle program. We've been looking at vendors. We've been partnering with the Constellation program to make sure that we're handing facilities over in a timely manner to both support Shuttle program and support Constellation program. But what I would tell you is we haven't reached the point yet of no return. Let me give you an example of Michoud assembly facility where we put the external tanks together. Our last ogive weld, which is really the first stage in how you put a tank together, is in December of this year. That's for ET-138. So we would do that ogive weld. We would have the no more need for the welding equipment to do that. Do you move it out? Well, no, you don't. You don't move it out until you have a pressing need for that floor space for a couple reasons. One is it costs money to move it, and I have to find somewhere else to put it, and I have to do all that work. So you wait until you don't need it, and then you need the floor space as well to move it out. So December is the last time that I anticipate needing to use that weld equipment. I don't anticipate moving it immediately off the floor, so you would have some capacity there. There's been discussion about vendors. We've been very careful with vendors. A lot of them you need to retain almost to the end of the program, just in case you have some type of a problem. You can reach back and use them. But we've spent a lot of time looking at the vendors, and I think we're going to have a good understanding when the study is completed as to what type of recertification we would need, if any, and what types of materials we would need to bring back as available to the program. The Kennedy Space Center infrastructure is going to be an interesting discussion. The plans right now, and I have absolutely no reason that we would change any plans, but the plans right now are to hand the high bay over to Constellation program after this flight. They'll have a mobile launch platform, they have a crawler transporter, and they have Pad B, so they have an entire string of equipment they could use. Could you process the shuttle in the other high bay with an MLP and Pad A? Yes, of course you could do that. So we're going to look at all these things. I'm a little bit concerned that while I don't think we would affect Ares 1 production, I'm worried about affecting Ares 5 production. And we're going to partner with the Constellation program very closely to understand what any impacts would be. And we'll come out of this study, I think, with a really good understanding of what our options are, and then we can go make an informed decision and help the next administration and Congress with that as well.
Irene? Thanks. Just a quick follow-up for Todd's questions. Irene Kloss with Reuters. Is that study going to be released for publicly, or are you keeping that internal in case you are asked by a new administration or Congress?
Keeping anything internal is kind of difficult these days. I don't know, Irene. What we're going to do is put it in a white paper format, and basically answering all the questions that we think are out there to be asked. And I don't know if the agency will release it or not. The program will provide it to headquarters, and they can release it if they'd like. Thanks.
And the other question I had is, I just want to make sure I understood this properly when you said this. I don't think I've ever recalled anybody in shuttle program saying that the greatest risk to the program is MMOD. I thought it had always been ascent issues, main engines and stuff. So just want to understand if that's really now that you're saying that the greatest risk for loss of crew shuttle is MMOD, and if that's the case, is that because of a change in the orbital debris environment, or because you kind of have more insight now with flying the OBSS and so forth? Thanks.
Yeah, it's an interesting question. In the past, MMOD, while a high risk was not the highest, mainly because there was not a good understanding of the criticality of damage on the reinforced carbon-carbon wing leading edge and the nose cap. We had some numbers that we thought were acceptable damage that upon further testing showed that it was not acceptable damage. So MMOD, as a result of that, was raised up in the total risk for the program. It was still eclipsed by ascent debris risk at the time, but we have, after factoring in the improvements we've made in the demonstrated flight performance, we've shown that the ascent debris risk has gone down substantially. So that has left MMOD as our most significant risk factor. It's followed fairly closely by SSME, by solid rocket booster problems, but MMOD is the #1 risk as assessed by the team. I'll tell you this too, it's not theoretical. Every time we fly the vehicle back, we have MMOD damage on the shuttle. If you look at the space station during spacewalks, you can see bullet holes in the station where it has gotten MMOD damage. We see small dings on the wings. We see holes in the radiators. We've seen that recently in flights. So we have seen MMOD damage on the vehicle. We just don't get it in critical places typically. Before, I'm going to add one more thing here. Before, I shouldn't pause so long, we didn't go look, and we didn't have any kind of repair capability. That's probably the biggest benefit we have gotten since return to flight is the boom with the sensor system, so that we can go look and do a late inspection to mitigate the biggest risk to the program, and then the development and success of our repair capability that is directly aimed at MMOD, and that's the plugs and the NOACs. So our knowledge has increased, therefore our risk has increased, but our ability to mitigate that risk has also increased greatly. So it makes me feel pretty good about it. Go ahead.
Tarek. Thank you. Tarek Malik with Space.com and Space News. John, you mentioned, I guess, the focus on the upcoming mission, and then kind of on the side, you're also kind of looking ahead with the study. And I was just curious, Bill Gerstenmaier said earlier today that there is a need for the agency to focus on the immediate mission ahead. You've got two set up, and it's the most, I guess, since you started flying again. And so my question is kind of how you weigh the future and the new administration and what it means for the program with this need for a focus on, the fourth shuttle of 5 planned for the year on a program level. And if you can kind of comment on that,
sure,
that'd be great. Thanks.
Sure. The team's priorities are absolutely clear, and the priority is this mission and the mission we're processing for rescue capability. There should be absolutely no doubt about that at all. We have the capacity to do studies and discussions and things above and beyond normal flight operations. We're at a point where the ground ops team knows exactly what they need to do for this mission. The flight control team knows exactly what they need to do for this mission. It's a very aggressive mission. It's very challenging. We have hazards that we don't typically have for an ISS mission that we have to keep our eye out for. And the team, from what I have seen, is extremely focused on the mission at hand and any kind of potential rescue mission. We are doing a thorough job on the study of identifying what questions are out there. We're going to do a very thorough budget assessment. We're going to do a very thorough assessment with the Constellation program and the ISS program on what the impacts of continuing to fly the shuttle would be. But that is not nearly in the same arena as flight operations, which the team takes very seriously. And I'll tell you this, Tarek, the team would rather focus on flying a mission and flying a vehicle than doing another study. So I don't have a hard time getting them focused on the right priorities.
Any follow-up, Tarek? Okay, Jeremiah, let's go start in the back over here with Mark on the back row.
Hi, Mark Kirkman, Interspace News. Since you did mention that launch on need is, you addressed it very seriously this time around, and it is different than in the past. So I was wondering if you can give me the big picture of how you're approaching it in terms of when you turn it on, when you turn it off. How far along does the other vehicle need to be? I mean, are you going all the way up to call to stations for SU-7? What posture does it need to be in?
The vehicle, the 400 vehicle will be ready so that if we turn it on, we can launch 3 days after we turn it on. And that's the condition that we're going to be in. So they will be in a kind of a standby mode where we're going to go up to a certain point, and Tony Sakaji can tell you all this tomorrow, exactly what point we're going to be at. But 3 days later, we would expect to be able to launch that vehicle. Second part of your question?
How far along does the other vehicle need to be? Basically, is it in a requirements point of view? Does it hold up the other?
Yeah. You know, we actually have changed that within the last couple of months. We had said since 400 really is for ascent debris mitigation, that after we do our Flight Day 2 survey, get all the data, process all the data, then we could stand down, start deconfiguring the vehicle on Pad B, and get ready to roll it over to Pad A for its 126 mission. We looked at the cost benefit of just leaving it on the pad ready to go all the way through late inspection, later in the mission, and it really doesn't affect the 126 plan at all. We have to do pad reconfiguration before it's ready to receive that vehicle. There are things we can do to the Endeavour stack on Pad B to get it ready to roll over. So leaving it ready to go throughout the entire Hubble mission was not a big impact to us, so we made that decision. We said we'll just leave it on the pad ready to go. If we find something out late in the mission, or if we have some kind of systems problem, although it's extremely low probability, we went to all this effort to get a vehicle out to the pad ready to go, you might as well leave it there while that one's on orbit. So I would expect that we would be in a position to be able to launch a rescue mission throughout the entire Hubble mission.
And if I may follow up, in terms of consumables, I mean, the common number typically is that you can extend a vehicle for about 25 days, but how far into the mission in other words, if you make the decision late in the mission, what does that do in terms of your overall ability to manage the consumables? And just to make sure I didn't misunderstand, the other vehicle will be all the way up into a Su-7 posture for the launch of 125, is that correct?
Yeah, let me make sure we clarify that with Tony tomorrow to get you exactly at what point they're going to stop. I'm not sure exactly what it is. I know we have a 3-day response time. The 25 days assumes that you knew very early in the mission, right off, that you were not going to be able to re-enter that vehicle in a controlled manner. And so you would go to a very aggressive power down to allow you to have that much time on orbit. If you remember, some of the studies from Columbia were out in that region, but it had the EDO pallet available to it, which provides additional cryogenics for the fuel cells. If we fly the normal mission that we plan on and found out very late that we had some kind of a problem, there's no way we could make 25 days. You'd be out in the 16-day kind of region. And Tony will bring all those in. They have studied this in great detail as to what, when you make a decision on power down, how long do you have from an orbital lifetime standpoint? Then what does that mean to you from a rescue vehicle capability?
Let's see, we'll get Irene. I'm sorry, Tracy. I was thinking Irene.
Tracy Watson, USA Today. I'm wondering, try and get back to a question that Bill Gerstenmaier addressed at the last briefing. Has there ever been any kind of comparable safety measure or backstop to having another shuttle on the pad? Can you think of another mission where something so significant and expensive was done as a safety measure?
What did Bill say? Yeah. I cannot. No, I can't think of anything that was this significant. I would tell you, though, that from a cost standpoint, this is not costing us a great deal, because this is not some unique thing just to the Hubble mission. We're going to use that stack, that vehicle, roll it right back over to Pad A, and go launch it on a mission. So it's not like a lost opportunity cost that you have. All it is that we stacked it earlier. We retained Pad B when we typically would have we would have liked to have handed that over to the Constellation program earlier to get ready for their Ares 1X flight. But from a cost standpoint, it wasn't that much. It just took some acceleration of the 126 flow, and then some unique mid-deck configuration to go fly a rescue flight. And it's just insurance for us. But no, I don't think we've ever done anything along these lines that would compare.
Yes, thanks. If you had to do a shuttle recertification, how big a deal is that, and how expensive would that, and how long would it take? What's your feeling on that? You know,
I apologize, Tracy, because Todd asked that question, and I realized I didn't answer it after I stopped talking. The orbiter recertification, we've gone back to the Cape, I'll just tell you that, to ask them exactly what they meant and exactly what was the basis for the recommendation that we would have to go recertify. And actually, what does that even mean to us? Because we do a tremendous amount of inspection of each vehicle from flight to flight, and we have significantly increased that since Columbia. So we're constantly going back and doing those types of things. We also have a 9-flight requirement that we do an orbiter maintenance down period, where we go and really take all the boxes out, do really significant inspections, wiring inspections, hardware inspections. It's hard for me to imagine what a recert would mean above and beyond what we would typically do for an orbiter maintenance down period. And we've increased all that. So we need to, that's part of the study, is go understand exactly what was meant by a recert and how that would differ from what we typically have planned in after a normal 8 or 9 flight flow. And then we would fold that into the discussion. That's going to be part of this study. Is we didn't plan on doing any more orbiter maintenance down periods. We were going to be able to fly out the rest of the manifest with what we have without doing any additional big 6-month down period. And we would have to go and look at how would we accommodate taking one vehicle out of the rotation to do the normal work that we would do, and fly the other vehicles until it's ready to go, and do that. We haven't put more than a week's worth of thought into how that would happen. There's a lot of options, as you can imagine. We're trying to skinny that down so we can have a white paper that will provide that information, those facts. So it's not at all clear to me what orbiter recert would entail. I think we are in a position with our normal planning where the vehicle is good to go after we do the normal work that we have planned for.
Let's see, we'll get Robert and then Mark.
Robert Perlman with Collect Space. With regards to the wrap-up on the repair to Pad 39A, are there additional precautions in place for this launch in terms of additional cameras being placed to watch it? And how does that affect the flow after you release Endeavour from STS-400 to rolling it back over to A?
Okay, I'm glad you brought that up. I should have mentioned it. Of course, we lost a lot of the refractory bricks veneer that's on pad A, and they took off a lot of the bricks on the sides of them, put in anchor bolts all around it, and then put a screen and then this fondue fire refractory material to replace it. But we didn't just replace the material. We also added a lot of instrumentation behind that refractory brick. We've got temperature measurements, acoustic measurements, acceleration measurements to understand the condition of the pad, which we really never understood well before. So we expect to gather a lot of data from pad dynamics when the vehicle gets SRB ignition and it lifts off, to understand that structural environment. Additionally, I asked the team to go off and look at some infrared cameras, since we're launching this one at 12:33 a.m. local time. It'll be dark. And go look at some infrared assets, to look at the plume, to look at some of those dynamics. Because what we understood after we had the incident where we lost the bricks, we had to go and recreate a lot of fluid dynamics models to understand what actually happens with the flow. That's something that we should understand, especially since we're so concerned about debris in the debris environment. There were some early reports that we had, bricks and material flying up really high. Well, it turns out that was water bagging into the solid rocket booster debris. But still, we should know that. And so we're going to have these new infrared cameras around the pad, looking at the plume area and looking at the pad structure to understand the environment better. So I'm kind of excited about it. We'll be able to hand the pad dynamics information directly over to the Constellation program, the infrared camera system that will provide additional data for something that we probably should have understood better in the past, but we just did not.
And in terms of Endeavour and releasing it from Pad B and bringing it back over to A, what's the turnaround do you expect in terms of being able to clear the pad post-launch of 125?
It takes about 8 days for them to get the pad where it's going to be ready to receive another vehicle. And if we don't have any significant pad damage that can be repaired in about a month, and we're able to get it from Pad B over to Pad A, then November 12th looks like a really good date for launching 126.
Mark, you'll wrap up the JSC part. Go ahead.
Thanks. I had a couple questions, and the first one goes back to the MMOD issue that you talked about. And I guess I'm looking for a little context or perspective. Are you seeing an environment that you think has been steady, or has it increased because of the Russian rocket breakup and the China missile test, or even the U.S. Effort to shoot down a satellite earlier this year? I'm just trying to get some perspective, because you talked about being able to really identify damage better than in the past, and I don't know if that's also a factor. And then if you could just discuss what sort of mitigation options would be reasonable for you to take, either in attitude of the spacecraft or whatever you might do, and is it likely you'll look at doing something like that?
The environment has gotten worse, and it's exactly what you described. We've had some vehicle breakups on orbit, and they have made the environment worse. It made our numbers. When I had some initial numbers about a year ago, when we looked at flying the Hubble mission, they were not as bad as they are now, and the result of that is because of the environment. We have already, because we recognize it as a significant risk, we have already taken all the actions we can as far as attitude timeline and putting the vehicle in a position where if we get micrometeoroid or orbital debris pieces coming at the vehicle, they come from typically along the velocity vector. So you'll see with our attitude that we typically will put the space shuttle main engines towards that part of the velocity vector, which doesn't make the Marshall guys very happy, but it protects the windows and the payload bay and the Freon loops and the RCC. And so they have optimized the attitude timeline as much as they can for this mission. You have thermal requirements for the space telescope that you have to meet. And we do our inspection, so we will know at the end of the mission if anything is required to go repair or not. Perspective, it's, like I said, we're about a 1 in 300 risk in an ISS mission. We're around the 1 in 180 risk for a Hubble mission. And just as a side note, we're refining those numbers, but I, as the program manager, can only accept a risk down to 1 in 200. So I can't accept the risk if it really comes in as a 1 in 185. So we'll have another discussion with the entire team, with the governance model. Engineering will weigh in, the safety team will weigh in, and this will eventually be an agency decision, I believe, at the agency FRR. Now, I'm going to hear the refined story at my FRR at the end of this week, but if the numbers are where I think they're going to end up, it's going to end up being a discussion at the agency FRR.
Go ahead, Mark, follow up.
Thank you. I think I'll just put my other follow-up aside to follow up on that one. That seems to suggest that if there was a number less than 1 in 200, if I'm following you right, then you really have to examine the whole issue of whether you should even fly this mission. Is that what you're sort of telling us, or? Not really. The 1 in 200 is a fairly arbitrary number that was decided upon kind of by consensus to make sure that we have the discussion and that the discussion takes place at the right level. And when you get to a risk greater than 1 in 200, it was decided that decision should be made at the agency level. And what I would expect the agency will do is they will look at all of our mitigation, late inspection, repair capability, the attitude timeline that we have. We're going to do an orbital adjust, translational burn late in the mission to lower the altitude of the vehicle after Hubble is let go. And that will decrease our MMOD numbers. So what I would expect the agency will look at, have you done everything that you can do to mitigate this? However, it's understood this is the environment, so this is the risk, and then it'll be up to the agency to accept that risk.
Okay, let's go to the Goddard Space Flight Center up in Greenbelt, Maryland for some questions there.
Seth Bornstein from the Associated Press, and I have a follow-up after this. Just to follow what Mark was asking,
Does this mean you'll require a waiver, an actual waiver, if it's not 1 in 200? And does it require from the level of a Gerst or Dr. Griffin for this? Who, if it's not, if it's still above 1 in 200, when you talk about the agency level, can you be a little more specific on who and whether it requires a waiver? And like I said, I have a follow-up.
Okay, the 1 in 200 from a documentation standpoint only exists in our orbital spec. It's not an actual program requirement, it's a project requirement. We would have to waive that, and this gets into the intricacies of shuttle program documentation, which is spectacularly uninteresting. So we would generate some paper that would say that we're not going to meet this project level guidance of 1 in 200, which is somewhat arbitrary. That would go forward to the agency FRR, which is chaired by Bill Gerstenmaier, and he would make a ruling on it. But with our governance model, in equal vote would be Brian O'Connor as the head of safety, and Mike Ruskevich, who is the chief engineer, and that discussion would certainly include Mike Griffin, as all of our significant program discussions include Mike, and it would be decided at the agency FRR. And this is I think one of the big strengths since Columbia, since the return to flight, is that we don't try to spin numbers or massage numbers or anything like that. We will just talk about what is the risk we believe to the mission, what mitigations have we taken to that risk, and then the agency, that will be Gerstenmaier, Brian O'Connor, Mike Ruskevich, Mike Griffin, will all hear that, decide if we have an acceptable plan, and go fly this mission.
And thank you. And to follow up, your predecessor, Wayne Hale, said, "We started shutting down the shuttle 4 years ago. That horse has left the barn." Can you explain why it hasn't left the barn, and what are the points of no return beyond the welding you talked about that are in the next 2 years?
Well, there's a lot of horses, right? And some of the things that we've been doing, yes, we've given up some capability. I mean, we destroyed the rigs and the platforms that we would need if we were ever going to put another orbiter together out of Palmdale. I mean, they showed the big orbiter tail servicing structure out of Palmdale in the parking lot. We reduced that to steel scrap. We've looked at a lot of different... The thing is, the shuttle program has lasted for 30 years. We've collected an immense amount of hardware, an immense amount of replacement parts, things that we clearly would never use again. We're not going to build another orbiter. And that is very easy to go and retire, transition, scrap, get rid of. That has occupied the team over the last 4 years. I mean, we have been spending that much time looking at it. We are rapidly approaching the point where we would have last build kind of activities, specifically out at the external tank. We have not passed the point where we have scrapped anything, moved anything out to the parking lot. We have, in this last budget cycle I had about a month ago, we were going to put aside $10 million for retiring vendors that provide hardware to the external tank project. Would we stop that? Well, not necessarily. What you have to look at is how much material do you have on hand. If you did shut them down and had to restart them, what would the business case for that be? What would the cost be for that? Or does it make more sense to keep going with them for another 5 or 6 months in order to keep that option open to you? So it's an unbelievably complicated problem. Even if we were continuing to fly and had never discussed, retirement or transition, we go through the same things on a daily basis. You have vendors go out of business, you recertify new vendors. You look at the amount of stocks that you have. Do you need to get someone available and producing some kind of component before you run out to keep up with your flight rate? So these are not questions that we're unfamiliar with. I would, from the look right now, the biggest points of interest are going to be out at MAF. When the Ares 5 comes along, The other one will be test stand capability out at Stennis and how we would manage that. I'm very encouraged because we have the Constellation program is working very closely with us in this discussion, so we will be able to describe the impacts very well. This is not going to be a shuttle program internal discussion. This is going to be in complete partnership with our ISS partners and the Constellation partners.
This is Alan Boyle with MSNBC. I had a couple of questions for John. One was getting back to that agency flight readiness review. At one point it sounded as if this was sort of an unprecedented new procedure, but your last comments made it sound as if it's similar to what was going on during return to flight, where you had heightened level of scrutiny, but it was the same basic procedure that you follow through for other flights. And then the other question was just how the team feels about this Hubble mission. Is there something special about going up to service Hubble that that gives a little bit of extra to the team?
Right. The process. No one is spun up at all about the. That's the kind of interesting thing about the discussion that we will have at the FRR, and that is because the process is so well defined. We know exactly what the process is. It doesn't bother me at all to come in with what we would call a red risk, which is a risk that I can't accept. We went through the exact same thing in the ice frost ramp discussions prior to STS-125, and the team knows exactly how to go about it and how to characterize it, and then we'll be able to make a decision. I would point out that we've had several independent groups come in and look at our governance model, look at the way we do business, and to a team, they have specifically pointed out the process we went through to characterize the risk for the ice frost ramps, the process that we went through with the safety community, the engineering community, the operations community, and the programs to understand and debate the risk, and it was seen as a great strength of the agency. It doesn't lie with one person. It is a discussion that brings the strength all across the agency to the table, so it can be discussed, and then we can have a good decision based on all the knowledge out there. So I think that's a very strong thing, and we know exactly what to do, and we'll go have that discussion. Hubble is special to this team. It is special because it is very challenging. It is special because of what it means to the greater community outside of NASA. There is great public adoration for Hubble and the pictures that it provides. For me personally, when I think of Hubble, I think Hubble defines NASA's character in many ways. When we first flew Hubble and it had problems, the team didn't just walk away from it. They resolved to go develop fixes for it, work very closely with the astronaut and operations community to install those fixes, and now Hubble is this great legacy as opposed to how it started. And I think that commitment and the perseverance really showed the character of the NASA and the scientific community teams, and that's what I think of with Hubble. I don't think of the pretty pictures. I think of the despair and the challenge, and how the team rose to that challenge and made it an unbelievably successful observatory. So Hubble has a great place in our hearts. I know the ISS guys are ready for us to fly back to station soon, but we'll take this short break and fly to Hubble and do our work there, and then we'll be ready to return and continue with the assembly of the International Space Station.
This is Dan Bergano from USA Today. I was wondering if you could talk just a little bit more about the integration of safety tasks and the repairs, EVAs and that sort of thing. Is this similar to ISS, or is it different in that you don't have the look back from the station and that sort of thing?
This is a really challenging mission. I would say this is probably, from a timeline standpoint, our most challenging Hubble mission, because it's the last one, and we have a lot of tasks that we would like to do. It's totally different from ISS. ISS is long translations, big things, a lot of movement. Hubble is small things and not as big of translations and changing out things that weren't meant to be changed out, which we don't really do on the International Space Station. So the feel of the EVAs is totally different. I mean, you're right there in the payload bay, but you have to be so precise and so careful. And so I think the skills and the focus of the EVA crew member and the team are different. You also have the ability, this will weigh into it a little bit, this is the last time you're going to see Hubble. And you don't have the option, if you don't get an EVA task done, of doing it in a stage on the ISS later on after the shuttle vehicle leaves. So there's a little of that thought too, that this is the last time we're going to be there. And I know the team has made sure that they have optimized the spacewalking timeline. They have trained it a tremendous amount, and they really know what they're out there to go do. I don't expect any wasted time, and I think the team will execute extremely well. Safety, we have the debates on safety, specifically with the gloves. You know, we've had some cuts on gloves. They've modified the gloves now, so we're flying these really neat modified spacewalking suit gloves that don't cut in the areas that we saw cuts. Do you have the potential of having a cut on Hubble? There's debate. You're not doing the long translations like you do on station, which we think may contribute to it. But Hubble's been up there for a long time, and it kind of goes back to our MMOD discussion. If you have an MMOD hit on Hubble, that could give you a raised edge, which could cause you a problem. The other piece is once we open the doors, we're working primarily on the interior of the telescope, where we don't expect any problems. So it's just different. But the team has addressed those differences, I think, in a very professional manner, and the team is ready to go.
Okay, that's all from Goddard. Let's head down to the launch site at the Kennedy Space Center for a couple of questions. Those will wrap up the briefing.
Hello, this is Marcia Dunn of the Associated Press. I'm wondering how new is the statistic for the MMOD risk for the Hubble flight of 1 in 185, presuming that's what it is. I'm wondering how long the number has been out there and about, and whether there have been any voices that you've heard saying that that number is too dangerous. And if you could review again the overall shuttle risk. I missed it, especially when you were comparing the overall shuttle risk to what this 125 will be in particular.
Marshall, we'll see what the number is at the end of the flight readiness review at the end of this week. It was not by a great amount, but it was above the 1 in 200 risk level that would cause us to bump it up to the agency about 6 months ago. But changes in the environment and better understanding of our damage criteria have moved that to 1 in 185. I'll know better later on if that's a good number or not. It doesn't really matter to me. If it's 1 in 185 or 1 in 205, which I can accept, we would do the same thing. We would bring forward, here's what the risk is, here's what our mitigations are, and we would have the intelligent discussion of are we doing everything we can do to mitigate that risk without affecting the primary mission. And so I don't get too hung up on the number. I want to make sure that the actions we're taking in response to the threat is appropriate. The overall flight risk, we've said 1 in 80 is what the agency has. That number, that's not the way I use risk numbers. They are not, I don't use them in an absolute sense. I use probability risk assessment in a relativistic sense in order to compare actions or changes that I might make to other actions or changes. So I look at something and decide, does it make me better or does it not make me better? And if it makes me better, how much? And then I look at that against resources. And that is how I use PRA, as opposed to an absolute, here's the number. that doesn't make sense to me because every flight that we fly is a learning experience. Every flight is a development flight. There isn't a flight that's gone up and come back down that we have not learned something from, good or bad, about the system, about the environment, about the way we go fly it. And once we learn that, we fold that into what we are going to do on the next mission. If we identify a new risk, we go try and eliminate that risk. If we can't eliminate that risk, then we mitigate that risk. So every time we fly, we learn something new. And comparing, saying I'm 1 in 80 for this flight, well, it'll be a different number next flight because I may learn of a new risk that I had on this flight, but the 1 in 80 did not take into account. Or I may learn that actually from the flight environment I'm safer than I thought I was, so it could change there. Every flight you have to look at it flight by flight, what do I know now and how am I mitigating that? So 1 in 80 is what the agency says. I'd say that's a good point in time number, but it can change next flight because we'll learn more from this flight.
Thank you. I guess I'll just follow real quickly by asking, so is there any number out there for the next Hubble flight, 1 in whatever? And secondly, has anybody voiced any concerns so far about the MMOD increased risk on the Hubble? And my last question is for the Launch on Need mission, was there any thought given to just launching 2 astronauts instead of a crew of 4 to reduce the potential loss of life if something bad happens?
I'm writing down questions now because I keep forgetting to answer them. Your question was, the first question was 180 we'll go with because that's what the current PRA says. That's fine. Hubble, is anyone concerned about MMOD is what you ask? Yes, we're concerned about the #1 risk in the program, which is MMOD. That's why we go to such efforts to do our late inspection, why we have worked so hard to develop repair capabilities. Of course, we're concerned about it. The team will listen to the discussion from this flight readiness review and from the agency flight readiness review to make sure that we've done everything that we can do to mitigate the #1 risk. You ask about crew of 4, crew of 2 on a rescue mission. We did have that debate, 2, 3, 4. 4 was recommended by the operations team and by the flight crew office because if you have 4, it allows you to do your full inspection that you would require to make sure that that vehicle is safe as well. So we took that recommendation and went with a crew of 4.
Okay, that's all the time we have for this briefing. Upcoming here shortly will be back to the Goddard Space Flight Center. You've heard the shuttle overview. Now you're going to hear the overview of the Hubble Space Telescope program and the 4th servicing mission to the telescope. So stay tuned for that shortly on NASA TV. Thanks a lot, everybody.
To Launch Complex 39A, getting ready for mission STS-125.
David works for the Kennedy Space Center and was on hand as the Space Shuttle Atlantis headed towards the launch pad on a device called the Crawler. The 77 metric ton vehicle goes about 28,000 kilometers an hour in space, but the crawl to the launch pad takes about 6.5 hours, not even 1 kilometer an hour. Atlantis is scheduled to launch in early October.